Hey, hello everybody. This is Jim Reddy, CTO, founder of Monte Vista. And today we'd like to talk about a pretty interesting subject that's dominating a lot of conversation these days. And I presume all of you have at least wondered about it, which is virtualization. And not just virtualization generally, but virtualization in embedded systems. Seems to be the new hot thing, and what we'd like to do today is just take some time and cover our thoughts about it, and maybe shed some light on what I think we really need to worry about as opposed to what might be easy to worry about, and there is a difference. But first, let's just take a look. Why does virtualization show up on our radar screen? Well, because it's a big thing, and it's certainly a big thing in the IT world. And of course, in many cases, things flow sort of downhill from the IT world into embedded systems, and this is no exception. Certainly the processors that are being built have extensive hardware support for virtualization, at least that which is found in the IT world. So it's a pretty fundamental property of the computing engines that we're seeing. So obviously we have to pay attention to it. So in the IT world, what were the conditions that led to this being such a phenomenal situation? And it turns out it's a product of the microprocessor in the sense of the way people would deploy servers in their IT departments, and it was relatively inexpensive to add another server for a particular application, kind of dedicate server per application, and works, and it was cost effective at some level. But with the enormous infrastructure required for the kinds of applications people are deploying in the IT world, eventually what people found is that their server rooms were full of servers, way too many of them, and they were wildly underutilized. And so you had a very particular situation, which is, in a sense, a relatively uniform technology, kind of built out pretty much the same way, and ending up being very inefficient, where one application on one server may only use some tiny percentage of the cycles that are there. And then you couple in with all the interesting green things these days, the fact that generated lots of heat, power bills, physical space, just inefficiency. And so what people are able to discover, and companies such as VMware, which have done extraordinarily well, is that there were tremendous savings to be made in the ability to consolidate and otherwise manage these server farms and sort of wring the last cycle out of them. So in a sense, you had a very inefficient, or you did have literally a very inefficient implementation that was ripe for technology such as virtualization that would allow a single server to host different operating systems, different versions of operating systems, and kind of break the coupling between one OS, one application, and one machine, and basically consolidate that across servers. And then of course there's layers and layers of efficiency that come with that, and the ability to move things around and otherwise do a lot. Huge business, billions of dollars being spent, huge savings, enormously powerful, and of course generates then all the buzz around virtualization. Gee, this must be a great solution for everything. Well, now we, as we always do, we say, well, let's take a look at embedded systems. And of course, that's our job. And well, it just so happens that once again, embedded is different. Doesn't mean there aren't some cases that overlap, but in general, if you look at an embedded system, say some box that Cisco builds, it gets stuck in that server room, but it's doing network processing or whatever, they aren't underutilized. In fact, embedded systems are highly optimized. Generally in a good one, every last cycle is taken out of those machines. There's no spare cycles, there's no inefficiency. Generally speaking, they're highly engineered. So the kind of the basic, discrepancy that was so obvious in the IT world, arguably has been engineered out of the embedded system world by the nature of embedded products. In other words, they are always, generally good ones at least, are built around cost containment and getting the most out of the box. So in embedded, we really don't have this sort of reservoir of inefficiency that we can kind of swoop in, put in a classic low-level virtualization environment and have all sorts of different embedded applications running on one machine. It's just generally not the sort of physical and logical situation that we find ourselves in. So once again, embedded is different. And there's I have to be careful how I say this, but there's another sort of operational way of measuring that, and that is there are embedded virtualization solutions, for sure, and they're good ones, technically very, very good, in sort of the parallel universe of virtualization a la IT, in other words, low-level hypervisors. Very good technology, absolutely deployed, useful to be sure, but the aggregate business that's been generated around that technology is vanishingly small relative to, say, VMware. And what it says is that whatever's going on in embedded, as usual, it tends to be highly fragmented, isn't a parallel universe to the IT world, and in fact probably has a different center of gravity. And that's what our point of view is. So although there is technology we inherit from the IT world, in fact what we did is we took a clean sheet of paper, so to speak, went to our customers, as most people probably do try to do, but nevertheless went to our customers and really looked at the use cases and so on that was leading them to sort of ask for virtualization. But I've been around long enough to know that you can't just sort of take that question at face value. You have to probe beneath that and understand what problem the customer is trying to solve. And that analysis is what's led to the MontaVista virtualization strategy, if you want to give it a name. And I think you'll see as we discuss it in more detail that it is fundamentally different, although it includes a little bit of what you might be familiar with, but fundamentally different than that which you find in the IT world. There's one other point that we'd like to make as we introduce all of this, and that is our approach, as it's been since we started the company, is try to do as much as possible with Linux. And if Linux can't do something that an embedded system would like to do, we go fix that. So obviously one of the first things that we did was what's a real characteristic, typical characteristic of an embedded system? Real time. First big project MontaVista put together, along with others, was to fix and enhance the real-time capabilities of Linux. The same holds true now for virtualization and kind of all the technology that might accompany virtualization. And that is, we took a look at Linux, we liked what we saw, we realized there's some gaps, we aggregated our list of requirements, and our point of view is that for a modern, especially multi-core system, where some form of virtualization may be useful, the way we solve that is with Linux. We don't have to introduce proprietary hypervisors, we don't have to introduce the old RTOSes, we don't have to sort of encumber ourselves with the past. We can show you in our approach to virtualization that in fact properly configured embedded Linux, obviously one from MontaVista, can cover the use cases that are required, do so well without having to introduce yet more layers of proprietary software and other pieces of sort of legacy code that you wouldn't otherwise have to have in the system. So that's our approach, which is use Linux, fix Linux, make Linux better, make it appropriate, and that's exactly what we've done. So it's a bit of a teaser to get you into the following 4 videos that we'll have. I'll just give you a sentence or two on each of the core technologies that we're concentrating on to put together this virtualization environment. Obviously, the first is Linux. OSs themselves are virtualizations of the underlying hardware, and what we've done with Carrier Grade, for example, continues in the tradition of very, very powerful Linuxes. Obviously, take a look at that. KVM will be there. It's the natural hypervisor technology supplied by Linux. Our claim to fame, besides making it work well in an embedded system, is making sure it works well on processors that typically aren't supported by KVM, MIPS, PowerPC, and so on. So take a look there. The sleeper in all of this, in our big discovery, and it's in Linux, but again, it needs lots of enhancements, is container technology. And basically what that is virtualization at the OS level as opposed down to the hypervisor level. Turns out, if you really look at what you're trying to do with most embedded systems, it's the hot spot to be in, and we're putting a lot of wood behind that arrow. And lastly, just to put the final nail in the coffin of using RTOSes, which then leads to having proprietary hypervisors and so on, we've done extensive work in reducing the overhead of Linux on individual cores, basically returning to the application what amounts to a bare metal environment. Super high performance, eliminates the need for an RTOS, and lets you solve the whole problem within Linux.